Good morning, everyone. Myself, Dr. Maheswara Rao, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics. The topic is capillarity. The course outcomes are, that means at the end of the student should be able to define the definition for the fluids and its properties and the surface tension. That is the course outcome one. And course outcome is related to the Newton's law of viscosity and classification of fuels based on the Newton's law of viscosity. And the problems related to the viscosity will come under the course outcome 2. Course outcome 3 is the capillarity rise or fall in a given tube. So capillarity means the fluid will rise above the surface of the fluid, or some fluids will fall, will drop the level whenever you keep a small tube. That is the course outcome 3. Course outcome 4 is the surface tension and its applications. Course outcome 5 is the capillarity and compressibility. The change of volume is called the compressibility. So course outcome 6 related to the frictional losses. That means whenever the fluid is flowing in a pipe, so because of the friction due to the at the surface of the pipe material and the liquid or fluid, so energy will be lost. So after traveling certain distance, how much pressure is reduced, what are the energy loss, those things will come in the course outcome 6, which is called here pipe flow. So today we are going to learn the topic capillarity. So you can see here the definition for the capillarity is the ability of liquid to flow. So here the liquid flow beyond the gravity. Gravity is not a gravitational flow. So liquid will flow by extending that gravity against the gravity also. So that is called a capillarity. So when will occur means in a small tube, small diameter tube or narrow spaces, okay, without assistance of the external forces or against gravity. So without using any pumps, any other external forces, the liquid or fluid will rise or will travel against the gravity. That means a gravitational power will act downwards, but here this fluid will go upwards. So that is called a capillarity here. The practical application for the capillarity this is a kerosene stove. So this stove is having this cotton bottle. Okay. So the kerosene will be here till the height of this or till the height of this only. Kerosene will be there, but this kerosene will rises and it travels to the top surface of this, so that here fire will occur. So this is happening due to the property of the capillarity. Here the thing is that these cotton threads will have micropores in it, so that those micropores will act as small tubes, so that the kerosene will travel from bottom to top at the flaming region. Okay, that's why the flame will occur. So this is due to the capillarity action. Similarly, for plants also, whenever rain comes, the rain goes and stays at below the ground level. So if it is a ground level, okay. So actually the roots are till here only. The water table is here. This is the water. So because of the capillarity, the soil also will have micropores. So this water travels upwards, which is called here capillarity. Because of this capillarity, the plants will survive. So if there is no capillarity here, then what will happen? These plants will not get the water, so that they can die. So these are the practical applications of the capillarity. One is kerosene stove flaming, another one is the getting the water for the plants through these capillarity actions. You can see here capillarity action or capillarity. So here capillarity action or capital, also called capillarity, is the ability of liquid to flow in narrow spaces without the assistance of the opposition external forces like gravity. Okay, here you can see two types of materials are here. One is H2O, that is water, hydrogen, that is a mercury. So here the water is rising here, and whereas mercury has dropped here. So it is a rise, it is a fall. So why it is happening, we will see now. And also you can see here the curvature at the surface. Here it is having this type, so concave. Here it is convex shape. So why it is happening, we will know it now. This capillarity action occurs when adhesion to the walls is stronger than the cohesive forces. Here two types of forces are there. One is adhesion force, another one is cohesive force. Okay. So what we'll understand, we can see here adhesion and cohesion. The definition for the adhesion is you can see if any molecules of one material will have more attraction power, more attracts other material molecules comparing to their own molecules, that is called a adhesion. That means here water molecules, the attraction between the water molecules is lesser than the attraction between the water molecules and glass. So here this molecule will have more attraction compared to these water molecules. These are water molecules. Here it is a glass. Here it is a water. So the molecules attraction between the water and glass molecules is higher comparing to the intermolecular forces of the water molecules. So that is called adhesion. So that means if adhesion is more than the cohesion. What is the meaning of cohesion? Cohesion means if the attraction is more, so same molecules of water, here one molecule, here another molecule, both are same material, or even in the same water, this force is more compared to other material. Okay, then that is a cohesive force. Here, not exactly water here it is a hydrogen. Okay, mercury. Okay, mercury molecules will have more cohesion. Okay, that means the intermolecular forces between the mercury molecules is more comparing to the attraction between the mercury molecules to other molecules like glass. Okay, which is called cohesion here. Okay, so and otherwise you can tell adhesion is the attraction between the two different materials, or cohesion is the attraction between the two same material. That is that one. Okay, so here that is the one. So you can see here capillarity action occurs when the adhesion to the walls is stronger. So adhesion means if this is a glass, if you keep this small tube inside the water, so the water will rise here because there is more attraction between this glass material and the water material. So that because that is adhesion, so more adhesion. That's why this water level is rising here. Okay, the height of which capillarity action will take water in uniform circular tube here. So, okay, is limited by the tension and of course gravity. So you can see these figures. So these are the two types of materials here. So this is water, H2O. This is Hg, hydrogen. That means the mercury. So if we keep a small pipe, small diameter pipe inside the water liquid or hydrogen liquid, so the rise will happen whenever you keep the small diameter tube inside the water. So this rise is called here extent of capillarity action. Okay, capillary action. And here, whereas hydrogen we can see here, okay, till here to here. So there is a drop. You can see here drop in the level. Actually, level of the hydrogen is this one, but here inside the tube it has lowered. So this drop is called the capillarity here, capillary action, because of the capillary action. Why means here it is a more cohesive forces compared to the adhesive forces. So because of more cohesive forces, it will attract the same particles of their own comparing to the glass molecules. So that's why it will have like this. Okay. Here, whereas this water is having this shape because adhesion property is more than the cohesion property. So that means attraction between the other material with other material is more comparing to the attraction between themselves. That's why the water level is raised at the edge of this glass. So if the water level is raised like this, that's why the shape is here. Here it is a reverse process. Okay. So this shape is called here meniscus. So meniscus is nothing but the top surface curve. The top surface curve in the smaller diameter tube. Whenever you insert in the water or whenever you insert in a mercury or in another liquid. Okay. These are concave shape, whereas mercury will have convex shape of meniscus. So here two things are there. One is meniscus, another one is the extent of capillary action. That means how much level is raised or how much water level is dropped here. That is the extent of capillary action. So meniscus is the top surface. It is a concave shape for the water, whereas it is convex shape for the mercury material. Whenever you keep in a smaller diameter tube, glass tube. So here meniscus formation. So the curved surface of a liquid in a tube concave. So if it is a concave shape means like this. So whenever it is adhesion is more than the cohesion, okay, it will be concave shape. Otherwise it is a convex shape like a mercury. And contact angle. So what is this contact angle? Influences the shape of the meniscus and the extent of capillary action. So if it is like this, so in a glass tube, okay, so this is the angle, contact angle. You can see here, so different types of liquids. So, okay, this is a liquid, over top is the air, here is also air, okay. So it is having a convex shape, it is having a concave shape. So what is this one, convex shape? So it is a mercury. So that means this one is a concave shape at the top surface. So it is a water. So you can see this contact angle. So, okay. So this is the meniscus having a convex shape, concave shape. So it will have force like this. This force is nothing but the 2 pi r into gamma. So what is this 2 pi r means? It is nothing but this 2 pi r is the perimeter of the smaller tube, smaller diameter. This is perimeter. So because this force is acting at all the points of this outer surface of this perimeter. So that's why the force is 2 pi r gamma or pi d into gamma. Okay, and this theta is the contact angle, and r is the radius of the small tube, and h is the height of rise of that particular liquid, and rho is the liquid density or density of that liquid. So there is a formula, capillary rise. So how much rise will be there for that particular liquid? It depends upon this formula. So what is this formula? 2 gamma cos theta and rho g r. So what is gamma here? It is a force or surface tension force. Okay, gamma is a surface tension force, and h is the height of liquid rise or fall. So it is maybe rise or it may be fall depending upon the property of the liquid. If more adhesion is there compared to cohesion, there will be rise in the tube. Or if adhesion is less or cohesion is more comparing to the adhesion property of the particular liquid, so more cohesive property liquid will have a drop in a smaller diameter pipe. So if it is a liquid, so it will fall like this. This is a drop. And R is the, here R small r is there, a capillary. So R is the radius of the capillary tube. Capillary tube. This is a capillary tube. And theta is the, this one theta is the contact angle. Gamma is the surface tension force. And rho is the density of the liquid. And g is the acceleration due to gravity. So today we have seen the definition for the capillarity. It is nothing but the ability of liquid to flow, through a narrow spaces without using any external forces or against the gravity. So some liquids will rise or some liquids will drop, which is called the capillarity here. The best examples for this capillarity action is the kerosene stove with cotton material. So that cotton will absorb, that means the pores, micro pores existing between the cotton threads will leads to capillarity action, so that kerosene will move upwards, so that flame will occur. Similarly, the water inside the ground will travel upwards because of the capillarity, so that it reaches the roots of a plant or tree, so that it will survive. These are the practical applications. And here there will be a rise and there will be a drop depending upon the property of the liquid. So it may be more adhesion, so there will be rise. If there more cohesion, there will be drop. Example for the drop is mercury. So if you keep the mercury in a small tube, the surface will drop. And whereas if you keep the same small tube in the water, the surface will rise inside the smaller tube. So it is called capillary rise. This one is capillary fall. Okay, meniscus, the top surface of the liquid inside a small tube, which is called meniscus. So that may be concave shape or convex shape. So water is having concave shape, concave meniscus, and mercury will have convex shape of meniscus. So extent of capillary action is the rise or fall, the quantity of rise or fall inside the small tube. So adhesion and cohesion, the attraction between the same particles, same molecules is having cohesion, whereas attraction between different materials is called the adhesion. And the contact angle is the angle between the surface tension force of the meniscus with the smaller tube pipe material. So here, so this we have having meniscus is convex and concave. So concave is water, concave meniscus, and convex meniscus is a mercury. So this is the force. Okay, 2 pi r gamma, and r is the radius, height is the rise of liquid, and rho is the density of the liquid. So the force for the capillarity rise, how much water, and how much water will rise in a smaller tube. The height is called here h, the height of a liquid or a drop of a liquid, depending upon the type of material, maybe water, maybe mercury, like that. So the formula is same, either it is a rise or fall. The formula is 2 gamma cos theta by rho gr. Here gamma is the surface tension force, theta is the contact angle, rho is the density of a liquid, g is the small g, the acceleration due to gravity, r is the radius of the capillary tube. And references are K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill's 2012, and Modi P.N. and S.M. Seth, Hydraulics and Fluid Mechanics, Standard Book House, 2002. Thank you.
Like, share and subscribe. hit the bell icon for more updates.